Okay, everybody, I'm going to go through some of these Khan Academy questions, and here you can see questions that most people got right. So I'm going to start here. Most of you who looked at this one saw that in places like this, if I drew a line there, it's going to hit that function more than once. So we see that x value 4.5, for example, has this y, but it also has this y, but it also has this y. So we can say, no, that's not a function. Most of you got this right. This is not a function. If I have the line x equals positive 6, then clearly x has an infinite number of y values. It does not fit the definition. Here, this is not a function because, again, some of these x values, this x value of 5, for example, has this y value, but 5 also has this y value, and it would not pass the vertical line test. This is a function. We will learn all about this. It's a quadratic function. So although I may see a y value represented more than once, okay? Here's a y value of 5. Here's a y value of positive 5. But it still meets the definition of a function because negative 1 only has 5. And over here, 5 only has 5. So I can see these y values appearing more than once, but each x can only have one y. All right, not as many of you saw this, but here we have these dots. Okay, so again, we're just looking, does each x have one y? Each x has only one y. If so, then we can say yes, that is a function. Same thing here, does each x have only one y? And the most missed question is right here. And I think maybe it's this part where people see that I have a y value of 6 appearing twice. But then what we really have to look at is this right here. So look at this. 5, the input of 5 has the output of 6. But the input of 5 also has the output of negative 6. So therefore, this input has 2 output values associated with it. So by the definition of a function, it cannot be a function. Okay, now we're going to look at recognizing functions from tables. So I have to read my wording here. Can the total distance be represented as a function of fuel? So that means distance depends on fuel. So when I see function of fuel, whatever is right here, that's my independent variable. Distance is a function of fuel, so distance depends on fuel. So I come over here in fuel. These are my x values. This is my domain, and this is my range. I have to know that because I have to distinguish, does each x value only have one y? So right away I see 30 appearing twice. But notice 30 only has 100. 30 only has 100. So let me check some others. 35 only has 120. 35 only has 120. And that's what I'm looking for. If each x, even though it appears more than once here, if each x is only associated with one y, meaning when x is 20, then y is 80. When x is 30, then y will always be 100. Then we can say, yes, that is a function. Okay. Here, duration is a function of time. So again, time over here, these are my x values. So I'm looking to see, do I have any repeats? So here I have the number 22, and here I have the number 22. Here, 22 is associated with 42. That's a relationship. But 22 is also associated with 41. So here, x has 2 distinct y values. So we would say, no, that is not a function. It's given to me a different way. Instead of numerical values, now I have 2 different things, a type of flower, function of a type of hat. So type of flower depends on type of hat. So type of hat, this becomes my domain. And I'm looking, okay, when I see beret, is that how we say that? Then I get daffodil, beret, daffodil. This only with this only with this. Is there any other thing that repeats? Do I see a beanie or a bowler? So as long as each X value only has one Y associated with it, then I can say yes, that is a function. Number of songs or number of videos Ruby's friends keep on their phone represented as a function of number of songs. So songs is my independent variable here. So I'm looking to see if I have any repeating numbers. Is there any number that appears more than once? I'm trying to hurry for this video, but it does not look like I even see a number repeated anytime. So therefore, each X only has one Y. And one more, actual attendance as a function of planned attendance. Actual attendance, can we say that that depends on planned attendance? Okay. So when I look at my values, 220 has 200, 220 here has 200. I don't see any of the repeating numbers, and so it looks like that would be a function. Okay, and finally, we're looking at linear versus non-linear functions. So now we're being asked specifically if we are looking at linear functions. And by definition, a linear function would form a straight line on the coordinate plane, and I would have a constant slope. So when I look at a data table and I want to measure slope, I have to measure the change in y divided by the change in x. So here, to go from 0 to -2, in my head or on paper, I'm thinking that's -2. So the difference is -2. That was my change in y. When my change in y is -2, my change in x is -3. So overall, if I do that as a proportion, that becomes positive 2/3. That slope is positive 2/3 because it's -2 divided by -3. So let me see if I maintain the same proportion for each difference. So -2 to +2, I say, okay, that's +4. 0 to 6 is +6. So the proportion, change in y divided by change in x, is +4 divided by +6. Well, that's the same slope as I saw here, which was positive 2/3. When I simplify 4 divided by 6, I still have 2/3. I need to check it for this pair. To go from 2 to -4, that's a difference of -6. So the change in y was -6. And while this difference is -6, to this change is -9. So -6 divided by -9, again, the slope is positive 2/3. So what I see here is that I have a common difference of positive 2/3. And I could even look right here, 0 to -4. That's a change of -4. If I do that, then the same proportion from 3 to -3, that's -6. So -4 divided by -6, I still have a proportion of 2/3. So I can say that has a constant slope, and I can say, yes, that is linear. All right, so let's check out another one. Let's look at this. Okay. So as I look at this, I see that as x is increasing by 1, y is also increasing. Again, I'd want to measure change in y on the top to get a slope. But here, the slope or the rate of change between these 2 points is 1 because it's 1 divided by 1. But automatically you can see here, this is 3 divided by 1. So already I can prove that that is not linear. It looks like it's a function from what I can see, but it's not linear because I do not have a constant slope. And if I were to graph that, I could very easily see that I do not get a straight line. Looking at a graph, I know this is not linear. Okay? There's no way for me to program y equals mx plus b into that Desmos graphing calculator and produce this curve. Okay? Linear functions take the form y equals mx plus b and slope-intercept form, and I would never get a curve like this by inputting x values into y equals mx plus b and getting those y values. So this is a function, but it is not linear. All right, I think we're almost done with this. I'm going to check this out down here. That's a curve, so it's a function. Looks like a function from what I'm shown. There's no way that's linear. That is not linear. That is not linear. Not linear. Not linear. And I was going to see if I see any more graphs. Hopefully you're getting the point, okay? That if it's linear, I should see a straight line. Like here's a straight line with a constant slope. Here the slope is 0, but it's still a constant slope. Here I have a straight line with a constant slope. That is a linear function. That is a linear function. So just to be clear, linear functions will be a straight line that either has a positive slope or a negative slope or a slope of 0. Okay? And I would see constant slope if I were looking at a data table. That's how I know that something is linear. It fits that definition and it fits the form y equals mx plus b. Anything else that is a function but is not a straight line with constant slope has to be nonlinear functions. I hope this helps.